Hi, Shivram. Thanks for joining.
Good morning. Thank you.
Are you located in the Bay Area?
Yes, I am.
Okay.
How about yourself?
I'm in Southern California, in LA.
Nice.
So we usually wait till 3 minutes past the top of the hour to.
No issue. Yeah, I
Yeah.
completely understand.
Hey, Jawad.
Good morning.
Jawad's the other co-lead, so.
Hey, Anu. Hey, Shivaram.
Hey, Jawad. Good morning.
Looking forward to your presentation today.
Thank you. Thank you so much. So the presentation is going to be short, but I have a demo. So what I've done is I've actually recorded the demo so that we don't get into any hiccups. So, and I have kind of shortened it a little bit. So.
Sounds good. There's also a long weekend here, right? So
Yeah.
I hope there's enough folks who show up, but we'll see.
Are you guys going to be in the Bay Area for the OCP Global?
Yeah. So the Global Summit is mid-October.
Okay.
And Jawad and I will be there through most of it, and then we have a whole day for the Open Chiplet economy.
Oh, okay.
Yeah, October 15th.
Nice.
So if you get a chance, it's on the schedule. So if you look for Open Chiplet economy on the main schedule,
Okay.
you should be able to see the talks and programs that we have, and that'll give you a good understanding of the work streams we have and the work we do and how connections can be made between potential collaborators and what we're already doing, or scope can be modified based on the needs.
Okay. Awesome. I'll check it out.
Thank you. Okay, we are 3 minutes past the top. Anyway, these are recorded meetings, so people come late or can't join, they will listen in. First off, I think just quick words about the Global Summit. Our program, October 15th, all day. I think we are very close to finalizing it. We have one panel, which we're still working on. And the reason that one is being modified is because of post APAC. We wanted to sort of tie the pieces together, and so that's waiting a bit. But other than that, most people have already submitted their slides, I think. There's only one or two left, so appreciate that. And it's a temporary placeholder for now, the slides. But final versions are due probably a couple of weeks from now. So let's get the temp ones in, and then we can work through to get the final versions. And then David and Javad, anything on Innovation Village that we want to talk about?
Yes, definitely. I want to talk about Innovation Village. So I wanted to, anybody who is interested in the Innovation Village would like to showcase some of their work, please do let me know. We are trying to finalize the setup and participation. So if you're interested, it's still not too late. Do let me know. Next week, I'll set up a meeting to quickly go over the details, the setups, and the requirements. So now is the time to let me know. I hope that everyone is familiar with the Innovation Village concept. So please let me know.
Yeah, I think even Shivaram, are you familiar with what this Innovation Village is? It might be a place for you to get a table.
Okay, I will look at that.
Yeah. I can connect you and David if you need any more information.
Yeah, I can say a couple of words just very briefly. So Innovation Village is a area, small area on the floor of the Global Summit, where companies can showcase products based on OCP technologies, specifically OCE, of course, right? That's our section. And is meant to be a pre-commercial release demos. Again, these are not meant to be company booths. The intent is to showcase some of the OCE technologies.
Got it. Is there a fee for this and that kind of stuff?
No, the space is free, but the passes to the conference are not complimentary.
Got it. So we are a
Right.
small startup, so I have to
Okay.
watch pocketbook. So that's
Yeah,
fine.
they do not allow company banners to be placed next to the tables. However, they do allow small tabletop kind of a printout with the company name. And I think one thing I want to do is that printout should kind of tell people what is being demoed. I felt that in last summits, yeah, we had the company, small company logos, but that it doesn't tell people what's going on there. So I can go over more details next week. If you're interested, do let me know.
Will
I
certainly.
I'm not sure if you have my address. If not, I can post it in the chat.
Yeah, that would be awesome. And also, I have my email address on the presentation deck and everything. So
Okay.
you will actually see it in a short while.
Right. Sounds good.
Thank you.
Thanks, David. Javad, anything from you? If not, we can get started with Shivaram's presentation.
Yeah, I think we can get started. There's really nothing else.
Okay.
Everything has been said. Thank you.
Shivaram, all yours.
Okay. Thank you. Let us see if this thing works. Okay. Sorry. Oh, Sorry, I will have to quit and reopen because my Zoom says with the setting I need to quit and open, otherwise you can't record. So I will be right back.
Sure.
Sorry.
Yeah, not a problem. Kevin, in the meantime? Kevin Donnelly?
I wasn't sure which Kevin.
Yeah, today I think we have only one. So, I think for the Shahab's portion of the optical, I'm going to try to get confirmation from him this week if he's going to be there. If not, I need to understand from him what it is we'd like to say, because I think we need to find a new rep going forward. So,
Agreed on all those points, and we've both heard him talk to the side, so I can do it if no one
okay,
else is available. But we do need to find someone to lead that effort.
Yeah.
Going forward.
thank you.
Cool. I'm back. Sorry about
Yeah.
that.
Is it possible to go on the presentation mode because you're sharing the split screen?
Am I? I'm
Yeah.
so sorry. Stop share. Oh, okay. Let's. How about now?
Yes, much better. Thank you.
Great, thank you. Thanks for catching that. So today we're going to talk about Wigs. This is a brand new startup. And what we're really building is how we can actually build silicon-like software, which is basically a platform. Think of it as a developer tool. It basically encompasses the entire life cycle of silicon, right from design all the way to tape out and beyond, including testing and all the other things. So we've been able to compress the timelines significantly, and as you can see, as we will see. My name is Shivram. So I'm basically have been a software engineer for the last 20 plus years. I used to work at Sun Labs, Sun, Microsoft, and Infoblox, both software products, strategy, and in between I've done a few startups too. And it's not like I was alien to Silicon, but at the same point in time, there was a problem that somebody posted a while ago, and I was trying to look for answers, and nobody could really help me understand what they were not really able to talk about it, and I started digging into it myself, and that is how I landed up building the entire thing. So with that said, so what we're really building, so in our vision, we feel that in about 5 years, we are going to be designing a chip just like software. I mean, it's going to be like writing a Python function, as simple as that. GitHub, if you remember when GitHub came, they basically democratized coding, and we no longer had all the source code control systems and everything, and we had a release engineer and so on and so forth in our enterprises trying to manage all of that stuff. All those things went away, and people were able to code, and they were able to code not only with confidence, but we also were able to do all the source code control and build in the best practices and so on and so forth. Hugging Face recently did a very interesting model. What they started doing was putting machine learning models and AI on their platform, and people started to consume it left, right, and center. And that's become kind of the go thing for today's AI and ML. And what we are trying to do is similarly for silicon. The problem today is that when I started to write code, RTL code, I wanted to see if there was an example or something like that that was out there. But the thing is that it was not like, okay, hey, import this library or and start building off a hello world out of this and whatever it is. I couldn't really find anything. That's how the software developers work, and I couldn't really find anything open source and being available and that kind of stuff. Everything was behind paywalled uh, organizations and that kind of stuff, and it was very hard. And so that was one of the challenges that I saw. And there was no really like a package manager, just like when we go to Linux or so we go and install a particular package. I mean, without even thinking about it, we believe that whatever operating system that we are using has already vetted the appropriate repositories and that kind of stuff, and we just blindly go and install and that kind of stuff. At least in terms of how all of these things are actually built. And there is also no curated software stack from a board support package point of view or OS images for some of the things that in Silicon that are built. And you also have two fragmented tool chains. And also one of the things that I think which is very important nowadays is basically how can you incorporate AI into all of these things so that you can actually accelerate the development and make use of it just like everybody else. So that was another thing. And the final point that I also saw was that there was not real software quality. I mean, people built their RTLs and that kind of stuff by naming them whatsoever. Very few people really followed the concepts of, okay, having a block name, module name associated with it, and how are you going to define all the type defs and that kind of stuff, and the whole nine yards. I mean, in terms of whether there's a consistent way to actually build it and run it and that kind of stuff and test it. So those are the kinds of things that wasn't there, and hence we built Wikes. And this is basically the platform moment. So what can you get out of Wikes? So sorry for this busy slide, but let's look at the top right. I mean, in simplicity, we start with a Wikes template. You just create a repository and you say, okay, you want to do a local development or you can do on a cloud. And you basically develop Silicon with an AI-assisted IDE. And what you get is all the reports and everything's built in. It's as simple as that. Okay, why does it matter? Okay, so we can actually do software development or silicon development like 60% faster. And one of the other cool things that in the last week to 10 days that I've also done is, so we have a standardized metadata structure, which is called WIGS metadata. And I looked at your CDXML and BOW specifications, and the PDF is like 40 pages long and that kind of stuff for the BOW. So what I did was I consumed all of that stuff and put it into my metadata, which you will see later on. It's going to be in a JSON format and that kind of stuff so that it's all machine readable, programmatically accessible and everything. So we have also incorporated AI into making all of these things faster and also predictable and those kinds of things. One of the things that to note here is that we are not really training LLMs. So you're going to be using the standard LLMs out there, like from whether it is from OpenAI, Claude Sonnet, Cursor, Copilot, whatever it is that they're providing. And what we are doing is that we are providing an AI co-processing engine, which basically takes a look at the entire thing within your repository and it stays with you. And it basically that is what is going to instrument all of these AI-powered IDEs to actually get you the whole experience of actually building all of these things, which we will see in the demo. And it's also a unified ecosystem. And we actually support both commercial and open source tool chain. So you can actually start with an Verilator, or you can start with Synopsys or Cadence tools or whatever it is. We don't have any problems with that. So we will support all of that stuff. The very fact that you can actually use open source tooling like Verilator, Yosis, and everything, K-layout to whatnot, I think it's a very powerful thing, especially for educators, or even if you want to give a particular project to a entry-level guy or somebody whom you can say, hey, come to speed or develop this small thing and then come back. So you can save on licensing money and that kind of stuff. So whatever it is that you want to do in your life cycle, we can support it. But the very fact that it is there and it is supported. So to that end, what we have done is that we have built a whole bunch of products around it to actually support all of these things at various stages. So we have the Wikes template that we are going to talk about very shortly, and we have the Y box, which is basically a complete all the tooling and IDE, everything in a box. And currently, it is delivered via cloud for free, and that is there. And you can go build your IP. And once you build your IP, I mean, hey, you want to say, hey, I want to build an AC card of this, or an FPGA, or a chiplet. It's your choice. You can do whatever you want. And then you want to commercialize it, like say, for example, you want to license it to somebody or you want to open source it or whatever it is. We have a product called YCL. Basically, it does the IEEE standardized signing, just like what you do for your encrypted RTLs for signing and licensing it out and that kind of stuff. And you can put it into our marketplace, which is currently their Y catalog, which we will see. And here you can actually buy it or you can just download it. And the YCLI, which is basically the tool, it's like PYPI if you're familiar with Python, or if you're familiar with RPM or sudo apt-get on Ubuntu or whatever it is. That's basically what the YCLI does. You can actually download, install IPs from the main repository or the catalog and that kind of stuff. So those are the kinds of things that we are actually doing. And we are going to be moving forward in terms of standardizing on development boards and how can we automate testing and so on and so forth. That's basically the whole enchilada of, in a nutshell, about what Wikes is actually doing. So with that said, I want to really do something here. I want to speak less, but actually take you to the demo. So with that. Let's do this. I'm going to start from here.
I think Shivram is just setting up the demo, right? I don't believe we have audio now, right, Shivram?
Oh, you can't hear the audio?
Oh no, I thought you were setting up stuff. We can't hear any audio.
Oh my goodness. Oh, shoot.
I was just waiting, and Cash
Oh,
actually asked the
thank you.
question. So
Thank you. How can I? This is actually coming out of the, I mean, of my video. So how?
Somehow need to share your system audio with Zoom, I think.
I see. Thank you so much for catching that. I have. How do I do that? How, how, how do I do that? Uh, do you guys know by any chance as to how we can do that?
any
The
suggestions?
hack might be to turn your speakers up and just play it loudly through your speakers so your
Okay,
microphone.
maybe that's what I'll do. Okay, my
Yeah.
apologies. My apologies. Okay, so let me back it up a little bit. Sorry about that. Okay, let me back it up a little bit. Okay, so okay, so basically what we are doing is that we are actually. Can you hear me now?
Yeah.
Okay,
Yeah.
great. Just making sure. We are on the Wix website. Everything that we do starts with the Wix website itself. We can actually build the IP right from here. The reason is that it is actually much more, GitHub supports the fact that you can actually build repositories from template and that kind of stuff. So that is what is really happening out here. And once you do that, then what happens is that you are, okay. And here, what I'm actually doing is that I'm actually creating a repository and I'm setting it into public. And what we are actually going to be building is basically the a component, the VQDQ vector dequantization and the quantization stuff from the Lyra Google codec that they have published. And they also have a GitHub repository in terms of a software implementation, and they have some test vectors and that kind of stuff. So we are going to basically use that as a part of this, and we're going to basically build a chiplet IP here. That is what I'm actually showing out here. So with that, okay, and that is what I meant by this one, and this is the repository that I was talking about. Okay,
So
and
what is the template that you use,
oh,
Shivram?
this is something that I have built. We have
Okay.
built, and what it does is, okay, we'll go there in a minute. Okay, here we go. And this, sorry. Okay, so this template has been created by us, and it's a standardized template. So you can actually say where is it that you want to go, where you want to place your RTLs, where you want to place your docs, the whole nine yards. So we have so that in that way there is no confusion for anybody as to how to lay out the directory structure per
Okay.
se.
This is
And
basically a directory structure format.
correct.
Yeah. Okay.
Directory structure format, and it also has templates on the file naming and so on and so forth. It also has our AI co-processing engine built into it, and it also has the templated GitHub workflows and that kind of stuff, so that you can actually build on top of it or modify it and that kind of stuff. So that is basically what it provides. It's what provides all the necessary scaffolding in order to quickly start building code rather than having to worry about, okay, where is my CAD engineer or whoever it is that is going to do, and where should I put this and that kind of stuff.
Okay. Yeah.
Get right into the design. Okay. So one of the things that I do is that once we do this, I git clone it to my local machine, and let's go here. Okay. And one of the things that I've done is that I have actually created a small text so that I can give it to my AI-powered IDE. I'm using Cursor. You could use GitHub Copilot or others. It's your choice. And basically, this is all that I have given them. I mean, given it. You can actually provide the more details that you provide, the much better the AI engines are going to be in terms of generating the appropriate code and that kind of stuff. And don't think of this as just vibe coding or whatever it is, because at every step, I mean, you as the driver really has to check. And my experience has been that sometimes it does fantastic things. There are certain things that it goes into a loop. I mean, at this stage of that's where we are in terms of AI today, but it's okay. And it actually does a fantastic job in so many different ways. And the cool part of it is it also does all the Coco TV test benches, make files, everything that are needed in order to make all of these things happen. So with that said, so this is, let's go
So
here.
here you're taking C++ code and building RTL.
No, I'm not even doing that. I'm actually using the Git. I'm not even taking any of their code.
Okay.
I'm just using, I have used that because there is test data available, and I've basically said, hey, you can use the test data from that.
Okay.
Okay, so that you can actually later on make a comparison and that kind of stuff. So that is the main reason as to why I utilize that GitHub repo, not for anything else. Okay, so this is basically the cursor, and okay, so this is what I did. I basically provided the same thing as I was mentioning, and when I did that, and the first thing that it actually does is it actually creates the Wikes metadata.json file. That's basically our metadata, and that drives everything. So think of this as the when you guys build the chip today, you build the entire thing, and at the end you generate an IP exec. What we do is the complete opposite. We build the Wikes metadata, which is much more comprehensive than the IP exact and that kind of stuff. And this is what drives it. This is basically the so-called master in terms of it has all the information that we will see, and then it gets kept on. It keeps on updating itself as and when you add more code or change the tests and that kind of stuff. So you always have a constant information, up-to-date information about where things are at this point in time. And that is very powerful because we use that same metadata later on in order to put it into the Wikes catalog and that kind of stuff. So you can see the source files, it has the whole enchilada. All the interfaces, chiplet information, test benches.
And so you're building, I saw you had a constraints file. So you're building a constraints file.
Yep.
Okay.
By the way, this demo timeline is like 14 minutes, which is like 10 minutes compressed. It took me around 25 minutes to build by the end of this. So just for your information.
Okay. Yeah. No, I think people can ask questions now during this.
So I'm going to move forward a little bit, and I'm going to basically. Yeah.
So you are building the metadata, not the design, right? Or also the design?
Yeah. So we use the first metadata, and as you can see, so we have actually built the design specification. That's the first thing that actually gets built. So while not the first thing, actually the second thing, after you build the metadata, okay, the next thing that really happens is, let me go here. Can you see is that it's actually building a brand new comprehensive specification and a detailed design architecture out here. You can see it on the screen.
Yes,
Okay.
but so you are not building there is no RTL Verilog code which is built, or it
The
is.
Verilog code is going to get built after that. So I mean, just like you have to do the design first and architecture, make sure everything is okay, and then you do the RTL, right?
Okay, so in this
That's the
demo,
thing.
are you right? There is an RTL at the end, or just the metadata and specification?
I'm sorry, can you repeat that question again?
So this demo, you create an RTL code,
Yes,
Verilog.
yes,
Okay.
yeah. So what this is basically saying is that before it does that, it actually says, okay, hey, let me create the architecture diagram here. This is how I'm going to do it. I mean, I'm going to lay out all of these. These are the file names. As you can see, it is using the block name, module name kind of a thing in terms of naming conventions and that kind of stuff. It does the whole thing. And it has the architecture diagrams and all the other things. So it built all of these things. And all the register information, everything is there inside this. I mean, it's very detailed. Okay. And then it starts building all the RTL code. Okay. And let's move forward. Hello. Okay, so and what I'm showing here is basically this is where the complete CI/CD stuff is, and so the docs are all here, and again it uses all the conventions so that it is actually there, and you can see that it in this it actually took the UCIe because I did not specify much, and it actually built it for the UCIe and that kind of stuff. So it's actually kind of interesting and powerful. So once you build all of these things, what happens next? Okay, so why is it showing? Yeah, okay. So now you can come here and you can go to the Y catalog. Okay. And this is what we have in terms of the Y catalog. This is actually on the website. You can actually go to wikes.com and you can actually look at this. And you can do a directory view or you can do a list view. Because we have very few IPs out here, I have the list view out here by default. But the cool part of it is that these are some of the IPs that we have actually built. And they're in various stages. They all have RTL and they're all working to a large extent. I think the next step is that we will actually start building ASICs and that kind of stuff. And we also have standardized reporting that comes along with this for each and everything. So because of this, you can actually publish all of these things. And what you can actually see you can actually see the gate size and die size. In this, the numbers are a little bit wrong because there is a mistake in my script and that kind of stuff. I haven't yet fixed it, but trust me, it is actually there. And I'm actually using like the USS generic tool out here. I'm not using any commercial tools. So once I use commercial tools for which I have to pay a license, so that's the only reason as to why I'm hesitating. And we will have all of that stuff. And once that is done, the other cool part of it is that I will also show you now. You can actually click on the waveform right here on the reports, and you can actually see. Okay, so you can actually see the complete waveform on the web too. So you don't have to go search for tools and that kind of stuff.
Shivaram, you said it used UCIe, right? So
Yeah.
then you did a big jump. So Does it create a UCIe controller and the logic for that, or does it have a library to call that, or how does it actually?
So in this thing, it hasn't really done that yet. Okay, but that would be the next few steps that I would actually go ahead and do it. I just took a small piece of the thing to actually do it in order to build all of these things. So these are certain things. The more and more information that I give, it's like basically saying, okay, hey, I mean, you build the house brick by brick kind of a thing. So that's the model that I follow. And yes, you have to build all of that stuff. And you can build it. I mean, it's going to take. I mean, the bottom line is that if it was going to be taking around 6 to 9 months worth of work to build all of these things, you can probably do it. You can get at least a good enough, decent MVP going in a week's time. That's basically how I would say. And this is actually real code. I mean, and this is actually high quality code that we are actually that's getting built. So one of the other cool things that we also have is that we also have the Y-Box. Let's see. Okay, here. So, and this is basically the cloud IDE. And GitHub has a product called Code Spaces, and it's free for open source repositories and that kind of stuff. And you can actually do a few. You can get fully AI-enabled cloud IDE with this. And what we have done is that we have actually built in all the Verilator and all the other open source tools into this. And you can actually start building right into the browser. I mean, you can use a Chromebook or even a Surface or whatever it is, and you can actually start building silicon today. And that's the cool part of this thing. And we have basically reduced the barrier to nothing so that people can actually start building all of these things. So that is what, hang on. Okay, so that was the demo. Any questions on that?
I think, personally for me, I'm just trying to wrap my head around you make it sound so simple to build silicon, but building silicon is actually pretty damn complex.
I know. I mean,
non-trivial.
Yeah.
And so I'm just trying to say, yeah, software is different. I agree. So I think that's the part. Setting up directories, all of that stuff,
Yeah.
I think is great because a lot of the headache comes in that portion. I just need to get comfortable with the rest of it, I think. And I think Cash's question about the UCIe, I mean, having a library, how do you have those? What kind of models do you need? There's a lot of questions in my head, at least.
Absolutely. I mean, one of the cool things is, I mean, you should also take a look at the repos. They're all Apache 2 licensed, so you don't really have to worry about any NDAs or anything like that. Okay. So that's the cool part of it. At least you can see not only this one, but there's some of the other ones that I have out there, like FFT and that kind of stuff. And especially the FFT, I mean, actually it was a good friend of mine. I mean, he's now retired, but at the same point in time, he's a DSP expert. And he basically said, hey, I am going to give you 5 lines because you're asking me, and can you build an FFT like this? And you can actually see as to how phenomenal the thing is in terms of how it was built. And just with open source tooling, I mean, if you look at the real reports, I mean, I was able to get it up to like 67,000 gates with absolutely, I mean, it's phenomenal. And he wanted like 50,000 gates or less. And if I use commercial tooling and if I do a little bit of work,
optimization,
you can get there. I mean, but the thing is that the very fact, and I'll be very honest, think of me as an illiterate in terms of silicon, okay? Because I don't have the kind of experience that you guys have. But I know software.
Right.
Extremely well. So so what we have also done is, I mean, now that you guys put out the CDXML and BOW specification and that kind of stuff, again, those are great. XML is great. I have been involved with that in terms of standards to everything 25 years ago. So I know that very well. But now with the machine stuff, we use JSON. So what I did was I consumed all of that stuff and put this. And if you can go to, I mean, you can go, these links are going to be are live and available and that kind of stuff. When you get the presentation, you can go check them out. They are the metadata. I mean, you can actually view all of that stuff. And within our chiplet, all that I had to do, I had a schema earlier. All that I did was I redid that schema in such a way that I incorporated the CDXML and the BOW specification into it and made everything else vendor-driven, vendor-customized, vendor-specific, vendor extensions. So in that way, I had best of both worlds in that sense. So you have UCIe, you have AIB, you have all of that stuff supported within this infrastructure in that sense.
Yeah, so I mean, if you just take a look at UCIe, right? Just focus on one thing. I mean, because you're throwing a lot of different things in there. UCIe has a controller, and then there's a PHY, right? The PHY architecturally is pretty simple, right? You have a clock, and then you have the data lines, and so on, serialization. So people charge, millions of dollars for that, right? So it would be really interesting for you to, I mean, you would have a line out the door if you could show, hey, UCI spec, here's the PHY, and this is how you get to, GDS2, right? So
absolutely.
I
would love to work with people. I mean, all that they have to do is that, I mean, if I can sit next to them and they basically say, hey, I want this and I want this, and I can actually help build all of that stuff.
Okay.
Just because
somehow, if you could demo,
yeah,
but what I was going to suggest was that's the demo people would want to see, right? So you start from a spec and you get to the GDS2, and it's showing the front end of describing something, whether it's CXML, there's XMLs up the wazoo, right? Which are describing something, but they're actually don't get you anywhere in terms of implementing it, right? So I think what you're saying is you can describe something in an AI language and use the tools like Cursor and so on to get to something useful that could then drive an actual product, right? So
correct.
I think that's...
But the cursor does not really do it by itself. That's the point. So what we have done is that we have built an AI context processing engine. Okay,
no, that's fine. That
is the one which actually drives it, because cursor only provides you, hey, develop this RTL for me. Yeah, it can generate some code for it. No issues at all, and it can probably generate very high quality code depending upon how you provide the requirements and that kind of stuff. No issues at all. But what it does not do is that, let us say that you change a feature, and then how do you make sure that the test benches are up to date? So because you change this will go and change the test bench. And or if you say, hey, we found some issues there was a mismatch in the pin configuration in the code in the RTL, it can go back and change that RTL and say flag that and that kind of stuff. So that is what this actually can enable you to do, all of that stuff. I know it is a little bit hard. I mean, even I was shocked when I actually did this. Trust me. So
okay.
I think, I mean, I think I have just one slide or something like that. But basically, what we have really done is that we have really done a vendor neutral chiplet IP repository. Okay, with Y catalog, it can basically take ASICs, FPGAs, or anything, because at the end of the day, what we are really doing is that we are putting the IP, which is basically RTL. Which can be for various different things. And it's also with all the CI automation and regression and that kind of stuff, we are actually setting up all the early stage compatibility validation that you guys have. And you also talk about best practices and reference designs and that kind of stuff. And that is where our templates come into play. And we talk about marketplace and ecosystem funnel. That is where the Y catalog is. And one of the things that if you go look at the web on our website, we also have a store and we will enable that in the real in some time shortly. That you can actually go really buy an IP and that kind of stuff. So I'm making sure that I'm working with ecosystem partners and that kind of stuff, and trying to make sure that we solidify all of these things. But it's coming up real fast. So that's all I can say. And the tooling support, I mean, we have both commercial as well as open source tooling support, and we are really trying to make this plug and play. Okay, just like software, validated, versioned, composable.
So this was, if I can interject, this was the slide I was hoping to see, the previous one, in the context of an open chiplet economy, right? And you know, a way of, you know, I think for this to have value in the open chiplet economy ecosystem, you know, in your demo you showed a lot of IP, which is, you know, I mean, you know, we've been doing IP integration for quite some time, right? And you know, I used to work for Denali. We had a tool that would integrate IPs based on their XML descriptions. Like we did that 15 years ago. What I think is new and important is the ability to you know, to integrate chiplets themselves, right? So to take it up a level and say, you know, the level of integration that we need in an open chiplet economy is a way to rapidly assemble chiplets in a way that is you know, managed and you know, has all the services that you need to do that. So yeah, I would like to see this as a chiplet integration tool rather than necessarily an IP integration tool. Although of course, you know, you can do both.
Correct. And you will see that, I mean, I have in my plans to actually put together something like that. We have that. It's now just the time and
Yeah. So I
That
just wanted to add some feedback
Sure.
and build on what Mark said. I think that if you come out and claim that you can develop the IP chiplets and all of this with this wonderful tool, I think it's going to be a very long road. But there is another part of this, which is, okay, you've got these chiplets, okay, and how do you even put them together, and how can they integrate and so on, and that may be a real opportunity for something like this. So, Mark, am I?
Yeah, exactly correct.
Yeah, I think we're so that's just two people in the industry with a lot of white hair.
Okay.
Who I just wanted to give you the honest feedback.
No,
right?
no. I mean,
if you come out and say I'm going to design an ADC and out pops your GDS2 or a UCI PHY, and you know, I think that is going to be a tough road. But there is already chiplets being developed, and there is a huge gap in the market. And actually, Raghu, I don't see if he was on the call. He's leading a group of trying to figure out at OCP how do you connect all these chiplets and validate them, right? And you know, so people are trying to solve this problem, and it is quite possible that is, you know, what you're sort of developing at the front end could be part of that. So maybe, you know, that's just some feedback for you.
Yeah. And I did have a call with Raghu, I think this a week ago or whatever it is, and I did show him this, and he said that he was thinking of doing a call for proposals by end of September or whatever it is. So that was his time, and that is what he talked about.
So that's what we're putting together for this virtual prototyping.
But I might actually have something really working. So, but at the same point in time, I would love to work with anybody anyone in the team to say, hey, let's crawl before we walk, before you run, and let me work with you in terms of saying, okay, hey, can we put these things together? Can we show something? And I'm happy to work with anybody in order to make this thing happen. But I'm basically a doer. Okay, I want to get things done. That's what we have. So that is what I have in terms of the slides.
Yeah. So Shivram, your last step there, which is catalog and marketplace. No, I don't know if you know, but the OCP has a Chiplet marketplace.
Yeah, they do. And what I have seen is it is more like a product store rather than IP per se. I mean, you can go buy cards that are chiplet based, but at the same time, I mean, you have the way I looked at it is that I was just looking at it. There is nothing wrong with all of these things, and you have basically proven all of that stuff in that sense. But the thing is that the way I looked at it was, okay, yeah, that is fine, but I want a chiplet that I could use or something like that is how I was looking at it. So, and that is what I have built. I'm
Okay.
not selling cards or ICs on my website.
No. So I think
I-
the marketplace is large, and then there is one category for chiplets.
Oh, okay.
And in that category, it's not just chiplet IP though. We also are open to anyone who plays in the chiplet ecosystem. For example, people who offer services
I
to
see.
the back end, people who build the BOFI or the UCIe FI. All
Mhm.
of those we consider as part of the chiplet ecosystem, which falls under the chiplet marketplace category. So we're trying to include everyone who plays a part in this ecosystem that someone who wants to integrate chiplets in their system is going to need.
Oh, okay.
So it's, yeah, so we're I think a little bit broader than just the IP. Of course,
Okay.
putting chiplet IP there is one part of it too. So
Okay. Awesome. Yeah, I'm basically looking at how can I accelerate silicon development. That is my main goal, period. And the silicon
it's a
can.
very good goal, believe me.
Thank you. So that's all I'm trying to. And chiplet is one form factor of the.
Of the whole thing, yeah.
So that is where we are at this point in time. And the other thing is that even with the catalog, Y catalog, and that kind of stuff, so we do have, we will have versions for corporates. So because the thing is that in many enterprises, they have large number of IP internally, and they have no idea as to what is it that they have built 5 years ago. Except, I mean, it's from tribal knowledge, or if you don't find the right person, you will not be able to get any of that stuff. But here we can actually, you don't need a CAD engineer or anything like that. You can actually look at the metadata file, and you can basically build a complete prototype, just prototype in the sense, a paper prototype at least, in terms of saying, okay, hey, these are the IPs that I would need. I can search for whether they support a particular interface, or whether they particular whether it is digital, FPGA, or analog, whatever that might be, and the chiplet. And you can basically make a list of all of that stuff and say, okay, which one you want to plug, and what is it that you want to, what's the gap, and what is it that we want to build for this. So those are all the kinds of things that we are interested in solving. And the other thing is that even in terms of how do you, now that you have the RTL and that kind of stuff, so we are also trying to automate how we can actually do the backend stuff in terms of how can you literally skew different kinds of silicon and that kind of stuff. Think of the Apple, or whether it is a Pro standard or the Max versions and that kind of stuff. Okay, so those are the kinds of things that we are interested in and we are working towards.
No, definitely. Thank you so much, Shivaram, for taking the time to come and present to
Thank
us. And I think there was a lot of questions. And
yeah, thanks. Yeah, you can feel free to reach out to me at any point in time. I would love to talk and see as to how we can all work together.
yeah, and if you could email me the version of the presentation that I can put on the OCP website, so it's open.
Yes, I will.
Let me know. Yeah.
I will send it. And the links are there. My apologies for not making the audio. I did not know as to how that would work properly. So now that I know, thank you. But the links are there. The audio is there. You can go look it up on YouTube too. So
Okay.
for your information. Thank you so much.
Thank you, Shivaram. Any other questions for Shivaram? Okay, I guess not. We gotta digest this, Shivaram. It's interesting coming from the software point of view. So
thank you so much. Thanks everybody.
Everyone. Have a wonderful long weekend.
Thank you.
And we will talk next week.
Thank you.
Bye.
Thank you.